Hello, students. Here we are on Lab Day, and we're going to do a couple of activities today, beginning with the one regarding that cool science word, osmosis. So let me hear you say it all together on the count of three. 1, 2, 3. Oh, come on. I know you can do better than that. Try it one more time on the count of three. 1, 2, 3. Yeah, osmosis, the diffusion of water. And so this activity is the classroom activity, which you can find in your book on page 44. Page 44. So take a moment and turn to page 44 at this time. All right, let's look at the problem together. It says, how do you expect to observe osmosis taking place with dried raisins? Well, here's the deal. We are going to be using raisins today to simulate or represent cells. Each raisin will represent one cell. And so we're going to take some raisins, which you may know are dried grapes, and we're going to complete this activity regarding osmosis. And essentially what we'll be doing is taking 10 dried raisins, determining their mass, plopping them into some water, letting them sit overnight, and then examining them the following day. So the question here is, how do you expect to observe osmosis? And remember what osmosis is. Think about its definition. How do you expect to observe osmosis taking place with dried raisins? So take a moment and write your hypothesis now while I head over to the virtual lab. All right, so you've written your hypothesis regarding this little classroom activity, our first of 2 experiments today. And, take a moment to share your hypotheses with one another. All right, you've got some pretty interesting hypotheses. So today, let me demonstrate this activity myself, and let's see how it relates to your hypothesis, and we'll make some observations together. First, we're going to begin with, I heard it through the grapevine, boom, 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 heard it through the grapevine. We're going to start with some California raisins, one of my favorite snacks of all time, packed with lots of yummy, sweet goodness and fiber, which helps keep you regular as well. So the only ingredients here are raisins, sun-dried grapes. So what I've done is I've removed, I think you can see this, I've removed 10 dried raisins from the box. I'm going to turn on our digital balance, wait for the zeros, and then we're going to determine the mass of 10 dried raisins, and we'll record that information in our books. So, that's a nice number. So here we go. We have our 10 dried raisins have a mass of 5 grams. 5 grams. So on page 44, make sure you're writing that down. The mass of raisins on day 1, 5 grams. By the way, little bonus here. We've got 10 raisins with a mass of 5 grams. What do you suppose that makes the mass of each individual raisin if they were all the same? Hopefully you said a half a gram, because if there are 10 raisins, all 0.5 grams, 0.5 times 10 is 5 grams. How cool is that? All right, so I'm going to take these 10 dried raisins now, and we're going to put that digital balance off to the side, and I'm going to bring in our next item here, our next material, which is a beaker of water. And you can see here, this is nothing more than a little less than 200 milliliters of just plain water in our beaker. Okay, and I'm going to do something with this beaker of water as per the instructions in our activity. We're going to take these 10 raisins now, and we're going to drop them into our beaker of water. Water is the key. We put them in water, and remember what the raisins represent. The raisins represent cells. And think about your question once again. Your question is, how do you expect to observe osmosis taking place with the dried raisins? So think about that. And we're going to let these sit for the next day. We're going to let them sit for a day before we come back for the next part of our experiment. So let's head back to the our notes here for a moment. And while that is sitting for 24 hours through the magic of media, let's talk a little bit about your expectations. Osmosis. If you look at this picture behind me, which you can probably remember from yesterday or the other day, a couple days ago, I showed you these examples of red blood cells and plant cells under different conditions regarding osmosis. And in the first column, we see what appears to be normal cells, normal red blood cells, normal plant cells. But in the second two cases, and you probably remember the story of our pet slug and the salt. All right, we don't want to reproduce that. But in the first example, we have what's called a hypotonic solution, a solution that has a greater concentration of water on the outside of the cells than on the inside. And as you know, the concentration, if it's higher on the outside than it's inside, if it's the diffusion of water, where's that water going to go? From an area of high concentration to low concentration. So in the second column here, this is what you might expect with cells in general. If there's more water on the outside than the inside, the cells may absorb the water because the water is going to an area of lower concentration. And unfortunately, that might result in not only a bulging of cells, but maybe even the explosion of cells. That would be bad, okay? In the third column here, we have a hypertonic solution, meaning one where there's no water, and things tend to shrivel up and dry out. In fact, it's this type of scenario that causes raisins to dry out in the first place. So let's pause here for a moment, and as we go back to our close-up lab view, 24 hours will have passed for the second part of this video. Okay, we're back on day 2. We're back on day 2 here for our classroom activity. And I have our friendly beaker of water, the same beaker of water that we had yesterday, with only 10 raisins in it. But check it out. Maybe you can see this. We got one floaty. We got one floaty on the top of the water. And as I hold this closer to you, you can probably see the water on the bottom is turned a little bit brown. And notice what has happened to the raisins. They look a little bit plumper. Now, what I'm going to do right now is I'm going to drain the water out of the beaker using a semi-permeable device called a strainer. And I'm going to remove the raisins, separate the raisins from the water so that we can determine the mass of just the raisins without the water on our digital balance, and we'll see what happens. So give me a moment. I'm just going to go over to the sink here and drain off our water. All right, here we go. I've drained the water off from our raisins. And let me just put this off to the side. Be right back. So here we go. I'm going to keep this one dry for the digital balance. We've got our raisins. I'm just gently, very gently dabbing the water off, jiggling them around to get all of the excess water off. And check out these raisins, man. Very cool. I'll line them up for you to see. They are getting plump after only one day of being in the water. Can you see how much bigger they are today than they were yesterday? So let's get the digital balance going here, and we'll get the mass. We'll get the mass of these raisins for day 2, and then you can finish up your lab activity. So I'm zeroing this out again. And now I'm going to place all of the raisins, all 10 raisins, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Good, we got all 10 of them. And we're putting them back on the digital balance, and let's see what their mass is. Oh my! All right, the new mass for day 2, 10 grams. 10 grams. These plump little raisins, all 10 of them, have a mass now of 10 grams. So a little question for you. If 10 of them all have a mass of 10 grams, what would be the average mass of each individual raisin? Hopefully you said 1 gram, which would be correct. Yeah, each of these raisins, well, think about this. Think about what they were yesterday and think about what they are today. And what I'd like you to do now for the next several minutes is complete the classroom activity at this time. And then when everyone is finished, we'll discuss it. But when you are finished, be sure to write your conclusion as well. So for now, we're going to be doing the lab activity in a little while, but for right now, I'm going to say bye-bye.